5 horizontal forces act at point P, which is in equilibrium. 4 of these are shown. So here we have point P, and we have 4 forces. 1, 2, 3, 4. The fifth force will be the resultant force. So calculate the resultant force on the point P in both vector and magnitude angle forms, giving our answers correct to 1 decimal place. So if we go to this GeoGebra app, which I will put in the notes of the video, here we see we have the 4 forces with the same angles. If I click on here, I get it in vector form. So this is us actually resolving it. In a minute we'll just do it more formally, and this will be the force. If I click on this one, I actually get to see the fifth force, okay, and the magnitude and in angle form. Now the good thing about this applet is if I move the forces, then of course that resultant force will change. So I can move any of these forces or get a different resultant. I can even make the resultant go up here if you wanted to, okay. So the fifth force will change if these to keep the system in equilibrium. Okay, if we go back now, this applet I will put in the notes of the video. So going back to this, so if we go to diagram, we mark on the point P, mark on the I and J axis, and we're going to resolve in the I direction, then we're going to, so this way will be positive, this way will be negative in the I direction. So we're going to have 44.5, the component of that will be 44.5 cos of 30 degrees, and then 72.5 cos of 50 degrees, and then 52 cos 45, but that's acting in the opposite direction, so we need to subtract that, and then we got 64.4 cos of 40, again that's acting in the negative direction, so we'll need to subtract that. Now if we work this out on our calculator, we get something that's like 0.996, so to 1 decimal place that will be minus 1.0. And now if we now resolve in the J direction, so in the positive is now upwards, so we're going to have 44.5, and the component will be sine of 30, plus 52 sine of 45 degrees. Now this one's acting downwards in the opposite direction, so this will be minus 64.4 sine of 40. So 64.4 sine of 40, and then minus 72.5 sine of 50. Now if we work that out on our calculator, correct to 1 decimal place, that would be minus 37.9. Therefore, the resultant in vector form will be minus 1.0 minus 37.0. Now, the magnitude of this vector is minus 1 squared, square root of minus 1 squared plus minus 37.9 squared. So again, that actually gives 37.9 newtons. Now to find the angle, well, this vector minus 1 and 37.9 is going to be over here. Okay, so if we think of the South Asian Tennis Club, or the quadrants, first, second, third, fourth, this is going to be in the third quadrant where tangent is positive. So we need to do tan to the minus 1 of the y component divided by the x component. Okay, so tan to the minus 1 of 37.9 over 1. We can make it positive because in here tangent is positive. That gives 88.5 degrees. Now, this is a third quadrant angle, so if we look at the third quadrant, this angle here will be 88.5 with this axis here. This is the positive I, and this is negative I, J axis. So the direction could be 180 plus 88.5, which gives me 268.5. So the magnitude angle form could be written as 37.9 newtons, 268.5 degrees. Now, normally the angle is given between minus 180 and 180. So we could write it as 37.9 degrees, 0.9 newtons, sorry, and we need to calculate this angle, which will be minus 180 plus, because we're going this clockwise direction, so it's minus 180 plus 88.5, which gives me minus 91.5. So either of these will give me the answer in magnitude angle form. This is probably the preferable one. Okay, so this has been a video to show you to find what a fifth force when you've got four forces acting on a point, and so that the system is in equilibrium. I hope you've understood, and I thank you very much for watching. And I'll remind you that the link to the GeoGebra applet will be in the notes of this video.